Hello, everybody. We're going to get started. I'd like to introduce you to John Andersen. John is on the open source security team at Intel. He's from Portland, went to PSU for computer engineering with a focus on embedded systems, and did his honors college thesis on machine learning. He's been working at Intel as an intern, then an employee for the past 5 years. Security research, embedded systems, machine learning, and DataFlow programming are his current interests. Let's welcome John.
All right, thanks guys. Thanks for showing up. So I'm going to talk to you a little bit today about Intel's dependency review process and how we automated some of it using machine learning. So who am I? I'm John. As was said, I'm an open source security guy at Intel. So I've been playing around a lot past few years with Linux, containers, concurrency, web apps, and Python and machine learning a little bit more recently. So while I was at PSU doing my undergraduate honors thesis, I did it on machine learning, and at the same time I was interning at Intel, and so I got the chance to work on this project where I got to apply some of the stuff I was learning about machine learning to a real application. So at Intel, we have a dependency review process that is part of the release process for any given piece of software. And so the software at Intel goes through this whole security process, right? And before you can release, you have to make sure that none of your dependencies end up on this ban list. Because a lot of software out there can be pretty bad, especially if you're just Googling for something and you find it on GitHub and it says it does AES and it's half the size of openssl. And if you went to Matt's talk yesterday, you might know why that is a bad thing and you should not use that. So we have this review form. It has a bunch of, you can't really see it, and this is not the exact same one that is the internal one. This is one that went through legal review. So it's got a bunch of little A through F answers, and for each category, looking at things like maintenance and security testing and like testing in general. And so what we were doing is we, as the open source security team, were put in charge of reviewing all packages for anybody's dependencies for all of Intel. And so Intel writes a lot of software, and so we were reviewing thousands of dependencies of open source software. And so we thought, well, it would be great if we could automate this because we have other jobs, like real things to do. And we don't want to be sitting there looking at open source packages all day. It's pretty mind-numbing. So we took this data set of the form answers, and John Whiteman and I took the same approach at this the first stab around. And so we grabbed this data set, we got the URLs to all these Git repos, and we have the review forms, right? So, and then we have the classification. So this should be a pretty straightforward problem, right? We should be able to take this form and then map it to the classification, train a machine learning model on it, and it should tell us, yes, this is good, or no, this is bad, based on our trained classifications. But we ran into a problem pretty much right off the bat. And that was that reviewers weren't consistently filling out these forms. And yeah, big surprise, right? So we're charged with doing this mind-numbing task that takes a lot of time, and we're really excited to go click every single drop-down. So part of the reason for this was that first, right off the bat, you could usually tell, or not usually, but you could sometimes tell whether something was good or bad right away, right? For signs like, has this thing written in 2005 and never touch sensed? Does it implement some crypto in a very non-standard way that, one guy wrote and no one else has looked at? Is it a parser? And so all of these things are early warning signs that we might just go, bad, right? You cannot use this thing. You may not ship with this software. There are also signs of things being good, right? This is systemd. Well, we may not like systemd, but you can use it. We know that people are maintaining it. So this was a failure. We only got around 60% accuracy. So we had to go back to the drawing board and think about, well, what is our approach, right? So if we don't have the data in the form, then we're going to have to generate a new data set, right? And so we're going to, instead of using that form data, we're going to generate some answers that are sort of like that form data, right? We don't know what they're going to be yet, but we know that there's some data that when you put it through a model, you will get something that tells you this is good or this is bad at a high percentage accuracy. Because after reviewing all these packages, we know that there were some things that we could put into numbers. We just didn't quite know what they were, right? It must be possible. So we took this iterative approach where we're going to generate this data set, train the model. If the model gives low accuracy, that means we have the wrong data set, right? So go back and grab some different features. So we came up with this plugin-based system, right, where we're going to scrape these different pieces of data that we're using as the features for the model. And that way we can, quickly swap in and out these features as we find out that this one doesn't matter or this one does matter. And it will allow us to, the idea is that we can swap out these features very quickly, and so that we can then find which ones matter, which ones don't. And ideally we have a simplistic framework to do this, because if I just want to count the number of authors, that should be as simple as git log grep authors sort unique, right? So that's very easy. But the problem comes into play when you start doing these, you start running multiple of these at once, and they're all running Git, and well, Git apparently actually does some weird lock files on repos, so you can't actually run Git concurrently. So if you want to scrape all of these repos and iterate on this, right, then you need this regeneration process for this data set to be fast, right? Because I can't sit here and spend 2 days regenerating my data set and then go back and find out that no, that wasn't the right set of features. It's going to be a huge waste of my time. So we needed to come up with something that gave us a little more flexibility around, like, how do we write these data scraping plugins without needing to know too much about the other things that are scraping data as well. So we came up with this framework that's basically like this. It's like a directed graph of operations that get run concurrently, while the execution framework deals with locking. So we define the data types, and we say, this data type needs to be locked before it's used in an operation, or it doesn't need to be locked. So the Git repo, for example, is a data type that needs to be locked. Once I've parsed some of that data, I can throw that data out, or I can throw that data back into this network of running operations, and I can now run things concurrently, or if it's just random data, we can run it in parallel, right? We don't want to be running things that are CPU bound concurrently. So then that releases the resource lock for the operation, for the other operations that actually do need to be working on the locked resource, like other things that need to go actively scrape the git log or whatever it is. So this is the directed graph showing how we would do a calculation of the number of lines of comments to the number of lines of code ratio, which was a rough estimation for how well documented is this code. And so what you can see here is we take the URL of the Git repo, we clone it, and then we're going to go find what the default branch is unless it was provided. So we want to detect if the default branch is master, or maybe it's like 5.3 point something. And then we're going to combine that. All of these, the other thing that was happening here is that we were doing this on a quarterly basis, so we were doing time series information, because as you can imagine, the maintenance of Git repos and the other properties of them are all varying over time, right? So somebody may start out doing coverity, or somebody may not start out having their thing in public coverity, and then they put it in public coverity, right? So quarter by quarter, these data points change. So we have a set of operations that goes and takes a quarter start date and goes back, X number of quarters, and then generates what are the commits associated with those dates for those various quarters. And since this is all running concurrently, part of also what happens here is all the possible permutations of every input set for any given function, which is also known as an operation, gets run. So as soon as you generate all of those quarter dates, it's going to go and dispatch all of these operations to run concurrently, and it's going to go say, okay, go grab with that default branch that you did and that quarter date, I want you to go, and for each, then it's going to say for each of these quarter ranges, I'm going to go scrape that, or I'm going to go check out that repo and then run this clock, or basically we ran clock, and then we did this division to find the ratio. All right, so this is how this execution environment works, and the nice thing about this is it runs everything concurrently, manages the locking, and it does this permutations of inputs, so you get every unique permutation gets run. So when we went to go, we go to plug this back, coming back to like the main framework here, right? We've got this system for doing plugins on the data set generation, and we also came up with a system for doing plugins on the models, the machine learning models, as well as a system for doing plugins on the data sources, right? So now we can iteratively swap out the data generation pieces, and then we can swap out the model portion, so we can go and say, you know, am I using scikit, which is what we started with, because scikit will tell you what are the feature importances of each of the pieces of data you're putting into it. So it might say, hey, you know, you gave me this ratio of how many comments per pull or are there a lot of comments on every pull request? Or, you know, what is the diversity of authorship? Like, how is each line of code committed by a different person? And so if you throw that through the random forest classifier, it has this nice property being like this classical machine learning algorithm where it can tell you that which pieces of feature data were important in it getting a good accuracy on the prediction. So that helped us throw out these things, right? But then once we got to a reasonable amount of accuracy, around 80%, I think it was like 82%, we said, okay, well, we want to go switch this to a better machine learning model, something that's hasn't been around for many, many years. So let's try doing some neural networks through TensorFlow. And so since we've got this plugin framework, we basically say generate the data. Now, instead of doing through the scikit model, do through the TensorFlow model. It's just a command line flag to say scikit to TensorFlow, and then now we're training using TensorFlow, and we get 90% accuracy. So that's good enough right there. So we're just going to go and start using this 90% accuracy to drop the band hammer on things as people submit them, so they don't have to wait for this 4 to 6 week turnaround to hear that they need to go change all their code because they used a bad dependency. And then, like I was saying, we also swapped in and out the data sources. So when we went to go take this into the production environment had this wacky MySQL setup. So we created this custom data source that knows how to interact with all these various MySQL tables, which is probably the case if you're going to integrate with an existing application. Like, you don't know what the database is going to be like. Well, you do know what the database is going to be like, and it's probably going to be custom logic, right? So you're going to go need to figure out how to integrate it with that custom logic, so you write a plugin. So this is what it looked like once it got integrated. It's pulling and pushing the data from that production database, and you put in the URL, it runs the data set generation, and then it runs the prediction through the trained model, and it says, yes, I think this is a good thing, or no, I think this is a bad thing. So what's behind all this? Well, we've got this wonderfully named library called DataFlow Facilitator for Machine Learning. And that legal gave me this name. So it's long and it's generic and descriptive. So what does this thing do, right? It provides the abstractions around sources and around data set generation and around models. And we've got a few baked in for you. But the plugin-based system does not require that you write a plugin that gets contributed back into the main source code of the repo, right? So people can publish plugins and then just like have them on PyPy or have them in their Git repos, and you can install them from people's random source, and it will work as a part of the existing ecosystem. So we've got sources for CSV files, JSONs, MySQL, and we've also got some models for TensorFlow and scikit to do a few things there. We provide a consistent API across the command line interface, the library, the HTTP API, and then by extension, the JavaScript API that works with the HTTP API. This is just like a bunch of console log from doing all the same things we were doing in Python, we're now doing from JavaScript, hitting the HTTP API. So then you have access to all these plugins. You install somebody's random plugin, and since it all fits in the framework, it knows how to extrapolate all the data you need to go configure that model or whatever and display it to you through this other API. So what else have we done with this thing? Well, we wrote this metastatic analysis tool for Python called Should I? And if you're familiar with Python or basically any package manager, you usually type pip install or apt-get install blank, right? So we created this thing that goes and it downloads the PyPy package that you were about to install, and it runs some static analysis tools on it. And right now, there's only 2 static analysis tools that it runs, but there can be lots more because we have this system where we're using these operations, and the amount of code that it takes to add a new plugin to analyze the source code is basically like, I think it's like 20 lines if it's auto-formatted with this thing that makes it really long. So we take the package name, we go grab the JSON information from the PyPy API. This is the DataFlow for that, right? And so then we extract the URL, we extract the version, we download the package contents, and we're running Bandit, which is like a tool that does source code analysis to look for things like SQL injections and stuff in your Python code. And then we also run this other tool called Safety, which goes and checks for like open CVDs or known vulnerabilities in packages. And so all of this runs concurrently, and then when you're scheduling out to subprocesses, because it's backed in async IO, the nice thing that will happen here is that when you call out to a subprocess, it automatically gets run in parallel. So you're getting concurrency and some parallelism for free. And also, if you're doing CPU-bound tasks, it's really easy to just say, hey, schedule this in a thread, and the orchestrator will go do that for you. So we've also got this concept where you can take these data flows, right, since we've abstracted to this level, we can take these data flows and we can deploy them in different kinds of environments, right? We could deploy this as a command line application like we did, where we say, should I install this thing? And it goes, runs them, and gives you the results. Or we could deploy this behind like an HTTP API, coincidentally, the same one that does all the machine learning models and stuff. So basically, we export to YAML files or JSON files, or whatever config format you want. Like there's a serializer and deserializer plugin, because if you haven't noticed yet, I like plugins. And so you can export these data flows, and then you could say like, run it. This is the specific data flow for the HTTP API, and you can overlay other things on top of that to extend it and say, so I had this base set of operations for this data flow, but now I want to create this new data flow, right? So I want to take these should I operations that we wrote, right? And one of them was download the package contents and run the Bandit operation. But now instead, I'm going to take the package contents, and then in parallel, concurrently, I'm going to link that into those existing Git operations that we had, right? And I didn't have to write any code. All I had to do was modify the YAML file, and now if you can see at the bottom here in this demo, it's giving you the lines of code, or lines of comment to line of code ratio. And basically, we have like a very small YAML file that gets in this overrides situation, and then you can like overlay different operations to create new data flows by chaining together these operations and saying how they should be connected. And so this is the graph that shows you how we took that package contents, and now we are using it we're using those other Git repo operations to, same code. All we had to do was tweak some YAML files, and now it's all running concurrently together. So where do we go from here? You can check out the machine learning integration usage example, which is basically very, very, very similar to the code that had to be written to integrate this within Intel's environment. You can also check out Should I, which is this metastatic analysis tool. And hopefully you guys can go contribute, because it should be very easy to write little operations. If you want to contribute, we have weekly meetings at 9 a.m. PST or PDT right now. And we've also got a Gitter mailing list, and the meeting links are on this website. And I just updated all the documentation and rolled releases this morning. So hopefully it all works. Any questions? Yes.
Hi.